This is CIE Paper 2 Further Pure Mathematics 2. And this is the most recent paper, October-November 2025, variant 24. In number 8, we need to find the set of values of A for which the system of equations has a unique solution. Because this is a system of three linear equations, a unique solution exists when the determinant of the coefficient matrix is non-zero. So let's start by finding the determinant of the coefficient matrix. I first write down the coefficient matrix using the coefficients of x, y, z. I then evaluate the determinant. When expanding the determinant, choose the row or column with the most zeros to make calculations easier. Equals to 5 times the determinant of minus 5 minus 3, 0, 1, minus a times the determinant of 22, 0, 1, and this is different from 0. It must be stated clearly. Implies that 5 times minus 5 minus a into 20 does not equal to 0. Implies that minus 25 minus 20a is different from 0. Implies that a is different from minus 5 over 4. Now, let's distribute the marks. There's an accuracy mark to say that a is different from minus 5 over 4, and there's a method mark to find the determinant. Here, they asked me to interpret this situation geometrically, and this has 1 mark. So I need to write this statement. The three planes intersect at a single point. And there's a basic mark to write this statement. In part B, it's given that a equals minus 5 over 4, and we need to show that the system of equations in part A is inconsistent. Inconsistent system means that the equations have no solution, and the three planes have no point in common. And then I have to interpret geometrically. Inconsistent means the system has no solutions, which means again no point in common. So here, it's enough to prove that two planes are parallel when a equals to minus 5 over 4. Let's substitute a in the equations above. So 5x minus 5 over 4y equals to 3. 20x minus 5y equals 2. And 2x minus 3y plus z equals to 1. Let's test equation 1 and equation 2. So 20x minus 5y equals 12. Here we multiplied equation 1 by 4. Equation 2 is 20x minus 5y equals 2. Multiply the second equation by minus. Notice here that the two equations have the same left-hand side but different constants, which is a contradiction. So when you add them, you will get 0 equals to 10. And this is the contradiction. This must be seen to take a basic mark. So we say plane 1 and plane 2 are parallel, and the third plane, 2x minus 3y plus z equals to 1, is not parallel to them. It's good here to mention the equation of the third plane. Now let's distribute the marks. You have a basic mark to mention that plane 1 and plane 2 are parallel. You have a basic mark to say that the third plane is not parallel to them, and it's better to mention the equation of the third plane. You have a basic mark to show contradiction, and a sketch is very powerful when words fail, and sometimes we gain a mark just by showing the sketch. In part C, we are asked to find matrices P and D such that A plus 3i squared equals P times D times P minus 1. The key idea here is that A and A plus 3i squared have the same eigenvector matrix. So we just find the eigenvectors of A and we use it for A plus 3i all squared. What about the eigenvalues? Adding 3i shifts every eigenvalue of A by plus 3. And by squaring this, we square those shifted eigenvalues. So this is the main idea here. The diagonal matrix, eigenvalue matrix of A plus 3i squared is equal to the diagonal matrix of A plus 3i squared. First, let's find the eigenvalues of A. Since A is a triangular matrix, so the eigenvalues are the diagonal entries. We start with determinant of A minus lambda I equals to 0. So we write determinant of 5 minus lambda, 20, 2, 0, minus 5, minus lambda, minus 3, 0, 0, 1 minus lambda equals to 0. Here we will choose the first row as it has the most number of zeros, so calculations is easy. Implies that 5 minus lambda times the determinant of minus 5 minus lambda minus 3, 0, 1 minus lambda equals to 0. Implies that 5 minus lambda times minus 5 minus lambda times 1 minus lambda equals to 0. So lambda equals to 5, lambda equals minus 5, and lambda equals to 1. These are the eigenvalues. So the eigenvalues matrix of A equals, we put the eigenvalues at the diagonal and we distribute zeros everywhere else. So the eigenvalue matrix of A plus 3i squared equals 5 plus 3 squared. Here we shifted by 3 and then we squared, minus 5 plus 3 squared, 1 plus 3 squared, and 0 in the other entries. This is equal to 64, 4, 16, and the other entries are 0. And this is our diagonal matrix. Now let's find the eigenvector matrix of A. Here I have two methods to find the eigenvectors. I'm going to use the vector product. So for lambda equals to 5, determinant of A minus 5i equals, I will put ijk, the unit vectors, at the top. Here I choose two independent rows from A minus lambda I and take their cross product. Now, to apply the cross product, you can use the determinant method and you can use the list twice method. And I'm going to use this method here. Listing twice method is a way to compute A cross product of B by writing the components twice, copy, paste under each other. Then ignoring the first column and then forming 2 by 2 determinants from the remaining columns to get I, j, k. So this is equal to 40i plus 80j minus 40k. And because eigenvectors describe direction, multiplying by a non-zero scalar does not change the direction. So here I divide by 40 to get a simpler vector. So my first eigenvector is 1, 2, minus 1. Now for lambda equals minus 5, determinant of A minus minus 5i, which gives me determinant of A plus 5i, equals determinant of ijk at the top, and then I choose two independent rows from A plus 5i. So I will choose 20, 0, 0, and 2 minus 3, 6. To find the cross product, I'm going to use listing twice method. So I will list the two components under each other, and then ignoring the first column, and take the 2 by 2 determinants of the remaining columns to find I, j, k. So I get 0i minus 120j minus 60k. Again, because eigenvector describes a direction, I can divide by 60 to get a simpler vector. So 0, 2, 1 is my second eigenvector. Now, for lambda equals to 1, determinant of A minus 1i equals ijk at the top, and then I will choose two independent rows from A minus I. So 20 minus 6, 0, and 2 minus 3, 0. Listing twice method, I will list the components above each other, ignore the first column, and find the 2 by 2 determinant of the remaining columns to get I, j, k. Here I got 0i plus 0j minus 48k. And because eigenvector describes a direction, I can divide by minus 48. So my eigenvector will be 0, 0, 1. This is a simpler vector. Since I have the three eigenvectors, I will put them as columns in P, which is the eigenvector matrix. So P equals 1, 2, minus 1, 0, 2, 1, 0, 0, 1. And this is the eigenvector matrix for A and for A plus 3i squared. And the diagonal matrix for A plus 3i squared is D equals 64, 0, 0, 0, 4, 0, 0, 0, 16. This is the eigenvalue matrix for A plus 3i all squared. Now let's distribute the marks. There's an accuracy mark for both matrices P and D. There's a method mark to find the diagonal matrix. There's an accuracy mark for the third eigenvector. There's an accuracy mark for the second eigenvector. There's an accuracy mark for the first eigenvector. And there's a method mark to find one of the eigenvectors. And there's a basic mark to find the eigenvalues.